All right, so we're going to look at solving what's called a literal equation. So a literal equation is an equation with more than one variable. So for example, let's look at number one. So here is an equation with more than one variable. So we have A equals D plus XY. So we have this equation, and there's actually one, two, three, four variables. Now, literal equations are not necessarily formulas in the sense that you think of. So when you think of formulas, you think of something like this that you've had before in geometry or financial math. So for example, V equals 1/3. Now this capital B means the base times the height. That's the volume of a right pyramid. Here's another formula that you probably remember from geometry. A equals 1/2 times B sub 1 plus B sub 2 in parentheses times the height, and that's the area of a trapezoid. So A here stands for area, and B1 and B2, remember, are the bases, the lengths of the bases, and H would be the height of the trapezoid. And then another formula that you dealt with probably if you in financial math would be interest. So the simple interest is equal to the principal times the rate times the time. So these are formulas, and you could take these formulas and solve for particular variables. You can also think of these as literal equations because these equations, see the equal sign, so an equation, these equations have more than one variable. But what we're going to look at here in these literal equations are not formulas that you would think of in using to solve geometry problems or financial math problems. These are, in most cases, just made up. Just equations where we have more than one variable and we're going to solve for a variable. So for example, number one, let's go ahead and solve this one for, let's say, x. So let's go ahead and solve for x. Okay, so when I look at this equation, here is the term that involves the variable x. And it's located on the right-hand side. Notice that on the right-hand side, there are two terms. The term that involves the letter D and the term that involves the product x and y. And there are two terms because terms are separated by addition or subtraction. So in this literal equation, I want to solve for the variable x, and the variable x occurs as a factor in this term. So I'm going to go ahead and kind of isolate this term. So basically, I'm going to kind of do something like this. I'm going to cover this up, which means I want to get rid of this term d. All right. So to get rid of that d, meaning I want to bring it to the other side, I'm going to have to subtract d from both sides. So remember, one of the properties you learned was that if you what you do to one side, you have to do to the other. So if I subtract d from the right-hand side, I have to subtract d from the left-hand side. All right, so you remember you have to keep your equation balanced. And so therefore I get, if I rewrite this, I get a minus d. So a minus d is equal to, and then d subtract d is 0. So when you add those up, that's 0. And then you're left with 0 plus xy, which is just x times y. So that's where we're at. Okay, now remember, you're trying to get x by itself. So right now, if you look at the term that involves x, which is this term here on the right-hand side, I am multiplying x by y. So remember, since I'm multiplying x by y, the opposite of multiplication is division. So if I want to get x by itself, right now I'm multiplying x by y, the opposite is to divide. So if I want to get x by itself, I'm going to have to divide both sides by y. So basically I'm going to say this, divide by y, divide by y. What you do to one side, you have to do the other. And then what happens when you simplify is that y divided by y is 1, right? And so I get x times 1, which is x, is equal to a minus d divided by y. And there's your answer. So you solve for x. All right, so that was number one. All right, number 2, let's suppose we had this one, number 2. We had capital B equals 1/3 times F m. Okay, 1/3 times F m. And in this case, let's say I want to solve for F. Okay, I want to solve for F. Now, notice in the first equation, I had 3 terms. I had 1 on the left-hand side, and I had 2 on the right-hand side. When I look at number 2, I have 2 terms as well. I have 1 on the left and 1 on the right. See, remember, terms are separated by addition or subtraction. There is no addition or subtraction here. It's all multiplication. 1/3 times F times M. All right, now, I want to solve for F. So this is the only term where F is located. See this right here? So what I need to do to get F by itself, at some point, I've got to get rid of this 1/3, and I've got to get rid of this factor of M. There are a couple ways you can do this. You could, first of all, let's get rid of 1/3. So one way to get rid of 1/3 is to divide both sides by 1/3. But that confuses students when you divide by a fraction. So here's the other thing I would suggest you do, and you learned this in a previous lesson. Let's go ahead and clear this fraction. So see right now my denominators are 3. So I want to clear this fraction. I want to get rid of this fraction. I want to eliminate that denominator. And so what you're going to do is this. So let me go ahead and rewrite this over. So right now I'm dividing by 3. The opposite of dividing by 3 is to multiply both sides by 3. So remember, what you do to one side, you have to do to the other. So if you multiply the right-hand side by 3, you're going to multiply the left-hand side by 3. And what I then get is this. I get 3b is equal to, now 3 times 1/3, the 3's divide out. You're left with 1's in their place. You're left with 1's as factors. 1 times 1 is 1. And 1 times Fm is Fm. So that's where we're at. So at this point, I've eliminated the fraction. But I still have to solve for F, right? So I have F times M, and now we know from the previous problem, where I had X times Y, to get X by itself, since I'm multiplying by Y, I'm going to divide both sides by Y. Same thing here. So to get F by itself, since I'm multiplying by M, I'm going to go ahead and divide both sides by M. And then simplifying, the M's divide out. M divided by M is 1. F times 1 is F. And I get F equals 3b divided by M. And you solve for F. And that's it. So that's number 2. So it's not that difficult. It's just taking an equation and you're solving for a particular variable just using properties that you've learned in the past. All right, let's look at number 3. Now, number 3, I have S equals 7 pi times C. And you want to solve for C. All right. Now, notice that this kind of, number 3, kind of looks like number 2, right? You have one term, one term. This one is kind of easier if you think about it, and it's easier because in number 2 you had a fraction. In number 3 you don't. Everything is divided by 1. See, S divided by 1, 7 pi C divided by 1. So if I want to get C by itself, notice when you look at the right-hand side, this means 7 times pi times C. And so if I'm trying to get C by itself, right now I'm multiplying C by 7 pi. So the opposite of multiplication is division. So that's how we got F by itself here. So I'm multiplying by M. The opposite of multiplying by M is to divide by M. And that's what you do here. So let's just go ahead and rewrite this over just to kind of show you. So if I want to get C by itself, I need to get rid of this factor. Well, I'm taking this factor and I'm multiplying it by C. The opposite of multiplication is division. So I'm going to divide both sides by 7 pi. And then 7 pi divided by 7 pi is 1. You get factors of 1. And then 1 times C is C. And you get C equals S divided by 7 pi. And there's your answer. All right, so that's number 3. Okay, number 4. Let's go ahead and do number 4 on another sheet of paper. So here's number 4. So number 4, we have b equals 1/5 m times, in parentheses, a plus b. And in this case, I want to solve for a. All right, now this is a little bit more complicated. Even though you kind of see one term here, because you have a product, 1/5 times m times this factor. So you can, at first, you can think of this as one term. I have a fraction, right? And I'm trying to get this a by itself. So this a, though, is in a parentheses that involves addition. So let's think about how we can proceed with this process, so that way somehow I can get a by itself. I have a fraction, so let's think about our previous problem where we had a fraction, number 2, and we saw that if I want to get rid of this fraction, first thing I did was I multiplied both sides by the least common denominator, or this denominator, which is 3. Do the same thing here. So that denominator is 5, so if I want to clear that fraction, I'm going to go ahead and multiply both sides by 5. So let's do that first. Let's see what happens. So I get b equals, I'm just rewriting this over, 1/5 times m times a plus b. So I'm going to multiply both sides by 5. So times 5 times 5. What you do to one side, you do the other. And so I get 5 times b is 5b equals, and then 5 times 1/5, the 5's divide out. You have 1 times 1 is 1. 1 times m is m, so I have m times a plus b. Okay? Now that's where I'm at. Okay. Now, you can proceed in this in two different ways. Does not matter. I'm going to show you both ways. So remember, you're just trying to solve for a, right? Okay. So here's what some students would do. So here's the a that I'm trying to solve for. I'm adding it to b, and this whole thing is being multiplied by m. All right. So what some students would do is, since this a is part of this parentheses, they're going to get this parentheses by itself. And to think about that, this parentheses is being multiplied by m. So the opposite of multiplying by m is to divide by m. So let me go ahead and rewrite this over just to kind of make it look a little bit better. So I'm going to divide both sides by m, just like this. See, just like that. So what you do one side, you do the other. The m's divide out. M divided by m is 1. So I get factors of 1 in their place. And look at this now. I have 5b divided by m, 5b divided by m. And by the way, make sure you're using the same variables, either lowercase or uppercase, that's being used in the problem. So this is a capital B, and this is a lowercase m, although it doesn't look like a lowercase m, but at least this looks like a capital B. So keep using the same capitalization. If this is capital B, use capital B. Don't use lowercase b. All right, so I get 5b divided by m equals, and then notice 1 times a plus b is a plus b. So that's where I'm at. See that? So this is this. Okay, now remember, I'm trying to get a by itself, right? So I need to get this by itself. Well, right now I'm adding b. The opposite is to subtract b from both sides. So to get a by itself, I need to subtract b from both sides, because b minus b is 0. And so I get a equals 5b divided by m, 5b divided by m minus lowercase b. All right, so that's why it's also important. You see there was a lowercase b here, so you don't want to make a mistake and make this lowercase, but then it becomes confusing because this was a capital B, and now you made it a lowercase b. So just make sure the notation you see here you keep consistent. All right, so you solve for a, and so that's it. So that's one approach. Now let me show you something else that some students would have done. Okay, see right here where we had this little part here? I'm going to rewrite this over. 5b equals m times a plus b. What some students probably did was this. So they see this parentheses, and this parentheses, these two terms inside the parentheses are being multiplied by m. So you're going to use the distributive property. And so when using the distributive property, you get 5b equals m times a plus m times b. All right, so someone could have done that. No big deal. We still have to solve for a, though. And so now I have two terms. You see that? There are two terms here. This is the only term that involves the variable I'm looking for. So I need to isolate this term. So meaning that I need to bring this term to the other side. Well, right now I'm adding MB. The opposite is to subtract MB from both sides, just like this. Oops, that's an MB. And so then I get 5B minus MB, 5 capital B minus M lowercase b, equals, this is 0, M times A. And then to get A by itself, right now multiplying A by M, the opposite of multiplying by M is to divide both sides by M. What you do to one side, you do to the other. Notice that all of this is being divided by M. These M's right here divide out. And now be careful, don't divide these M's here because this M is also being divided into 5 times B. So be careful. This is mathematically incorrect if you divide those M's out because that M is also being divided by 5, is being divided into 5B. So I get 5 times capital B minus M times lowercase b divided by M is equal to A. And there's your answer. You might say, well, that looks different than this. Well, yes, it does, but they're actually equivalent. So let me show you. Let me show you this. See this right here? I have 5B minus MB divided by M. I have two terms divided by a monomial, right? So I can break this down into two fractions. So I get 5B divided by M minus MB divided by M, and then simplifying or reducing, these M's divide out, and I get 5B divided by M minus B, which is what this is. See that? So those are actually the same. But notice the box part would be the answer you would give me. So if you do it this way, this is what you get. If you do it this way using distributive property, this is what you get. All right, but they are the same. We just saw that this is the same as this using this process. All right, so that was number 4. So it's not that bad. All right, number 5. Let's look at number 5. Number 5, we have capital H equals 2AB plus 2AC. And I want to solve for capital A. All right, now, look at number 5 this time. So on the left-hand side, the right-hand side is the only side that involves the letter I'm looking for, the variable I'm looking for. But this time, the letter A is in two terms. It's in all those terms. Well, you learned about factoring, remember? One of the things you learned about factoring is that if you notice those two terms, they have an A in common. They also have a 2, but I'm going to leave the 2 alone. All I'm going to do is I'm going to factor out the A because that's what I want to solve for. So for this part, since the variable A is a factor of both terms, I'm going to factor out the A. So I get H equals A times 2B. See, when I factor out the A, I'm left with 2B plus, and then factor out the A, you're left with 2C. Just like this. And then if I'm getting A by itself, notice right now, to get A by itself, notice though that I'm multiplying A by this set of parentheses, this expression, 2B plus 2C. The opposite of multiplication is division, right? So let's just go ahead and rewrite this over. So this is what I have. So remember, the opposite of multiplication is division. So if I want to get A by itself, then I'm going to divide both sides by whatever I'm multiplying A by. So I'm multiplying A by 2B plus 2C. What you do to one side, you do to the other. And so these divide out. 2B plus 2C divided by 2B plus 2C is the factor 1. A times 1 is A equals H divided by 2B plus 2C. And there's your answer. So that was number 5. Number 6, we have this. We have 1 divided by A plus 1 divided by B equals 1 divided by C. And you want to solve for C. All right, so remember we dealt with fractions before. Notice, though, that in number 6, I have 3 sets of fractions. This denominator is a factor A, this denominator is a factor B, and this denominator is a factor C. So what I want to do is I want to multiply both sides by that least common denominator. And so the least common denominator must include every factor you see. So I see an A, I see a B, and I see a C, right? So my least common denominator is going to be A times B times C. So remember, the least common denominator is a product of these factors that you see here. So then what I'm going to do is I'm going to multiply both sides by that least common denominator to clear the fractions. So I get ABC times the left-hand side, which is 1A plus 1 divided by B, equals, and then multiply the right-hand side by the least common denominator also, ABC times 1 divided by C. All right, now, in the previous section, you learned about the distributive property. So at this point, I introduced a set of parentheses, so to speak, although those are brackets, but it does involve the distributive property. So I'm going to multiply both of those fractions by the least common denominator. So I get ABC times 1 over A plus ABC times 1 over B equals ABC times 1 over C. Okay? And now let's go ahead and simplify. The A's divide out here, the B's divide out here, and the C's divide out here. So I get 1 times BC times 1 is BC, plus A times 1 times C times 1 is AC, equals, and then A times B times 1 is AB. Okay? And remember, I'm trying to solve for C, right? So remember the previous problem where I had these two terms having the variable I'm looking for, so I factored out the A? Notice, these two terms have the variable I'm looking for, so I'm going to factor out the C. So I get C times B plus A. Make sure you understand that. C times B is BC. C times A is AC. All right, so I factored out the C. Equals A times B. And now notice, I want to get C by itself. Right now I'm multiplying it by this expression, B plus A. The opposite of multiplying by B plus A is to divide by B plus A. I'm just going to rewrite this over. So I'm going to divide both sides by B plus A. And so the B plus A's divide out. You get C times 1 is C equals AB divided by B plus A. And that's it. There's your answer. Okay. Now be careful. Don't make the mistake of simplifying this. Some students, when they see an A in the numerator and an A in the denominator, they want to automatically cancel out or reduce. You cannot do that here because this A, which is a factor of the numerator, that A is not a factor of the denominator. The factor in the denominator is B plus A. See, this is addition. This is not multiplication. All right, so you just got to be careful. The same thing for B. You cannot divide out these B's because even though B is a factor of the numerator, it is not a factor of the denominator. Number 6. All right, let's look at number 7. Number 7, I have x plus 6y equal 8. And you want to solve for y. Notice that on the left-hand side is where the y is located. There are two terms here, and this is the only term with y. So what I need to do is get that 6y by itself first. So let's go ahead and get rid of this term x. I'm going to go ahead and subtract x from both sides. What you do to the left, you do to the right. Kind of makes sense to do that because x minus x is now 0, right? And so you get 0 plus 6y equal 8 minus x. And then, to get y by itself, notice I'm multiplying by 6. So just as before, the opposite of multiplication is division, so I'm going to go ahead and divide both sides by 6. And so 6 divided by 6 is 1. 1 times y is y, equal 8 minus x divided by 6. And there's your answer. You got y by itself. Number 8, let's do one more. Let's look at number 8. So in number 8, we have d equals a minus b divided by 3. And you want to solve for, I'm sorry, this is a plus b, excuse me, a plus b. So d equals a plus b divided by 3, and you want to solve for b, okay? All right, so notice that I have b located here, so I want to get this by itself, but I'm adding a, right? And then I'm dividing all of this by 3. So think about this strategically. How can I get b by itself knowing that I'm adding a, and then I'm also taking all of this in the numerator and I'm dividing by 3. So notice the best way to do this first is to think about, hey, I'm dividing by 3, so I have this fraction, so let's clear that fraction. Let's get rid of that 3. And so one way to get rid of the 3 is to multiply both sides by 3, because you're dividing, right? The opposite of division is multiplication. So times 3 times 3. And so I get 3d is equal to the 3's divide out, a plus b. And then notice how simple this is now. To get b by itself, you want to isolate this variable, this term b. Well, right now I'm adding a to it, so then you're going to subtract a from both sides. And so I get 3d minus a equals, this is 0, b. And you're done. That's your answer. Not very difficult, is it? Let's look at this. And I said I was going to end with that one, but I want to do this one. Let's look at number 9, just to kind of see how would you approach this. So number 9, I have d equals, this time let's say d equals a minus b divided by 4 this time. And let's say I want to solve for b. And the reason I'm doing that one is because notice that when I, at this point, when I got b by itself, that was a positive b. When I get b by itself, it's going to end up being a negative b. So there's going to be one little extra step you're going to have to think of to get b by itself. So let's go through that and think about it. All right, so to get b by itself, this b here, right now I'm dividing this whole numerator by 4. So let's go ahead and multiply both sides by 4. So I'm just going to rewrite this over. And so I'm going to say times 4 times 4. So I get 4d equals, these 4's divide out, and you get 1 times a minus b is a minus b. And to get b by itself, even though this is subtracting b, to get b by itself, let's get rid of this a. To get rid of this a, we're going to subtract a from both sides, because a minus a is 0. That's what you wanted. So I get 4d minus a is equal to, now be careful, this is remember, this is 0 minus b. 0 minus b is a negative b, so that negative stays with that b. So just be careful. Now, you want to get b by itself. This is a negative b. Now remember, negative b means the same thing as, say, negative 1 times b, right? So some of you may want to think of negative b, or the opposite of b, as negative 1 times b. If you want to think of it that way, do so. It may help you. So this is what we have. We have 4d minus a is equal to negative 1 times b. But I want to get b by itself, not negative b. So right now, to get b by itself, right now I'm multiplying b by negative 1. The opposite of multiplying by negative 1 is to divide both sides by negative 1, just like that. And so I get 4d minus a divided by negative 1 is equal to, now notice right here, negative 1 divided by negative 1 is a positive 1. Remember, negative divided by negative is a positive. Negative 1 divided by negative 1 is a positive 1. 1 times b is b. So I have this. Now, I'm going to write this over because I want to say something. So I have 4d minus a divided by negative 1 is equal to b. Now, algebraically, we don't leave 1 or negative 1 in the denominator. So the way I want you to think about this is this. I'm dividing 4d minus a divided by negative 1. All right, so I want you to think about this for a moment. If I have 6 plus 3 divided by 3, let's say, you all know that I can rewrite this as 6 divided by 3 plus 3 divided by 3, right? So 6 divided by 3 is 2, 3 divided by 3 is 1, so 2 plus 1 is 3. So this right here is equivalent to 3. But the point is that I want you to recognize that I can take each of those terms and divide it by that numerator. That's what you saw here. So I want to do that here. So I'm going to take each of those terms, I'm going to divide it by negative 1. So I get 4d divided by negative 1 minus a divided by negative 1. And at that point, here's what I want you to think about. So let's think about this for a second. If I have 8 divided by negative 1, y'all agree that's the same thing as negative 8, right? If I have negative 8 divided by negative 1, do y'all agree that is a positive 8? Okay, I'm going to use that idea here. 4d divided by negative 1 is a negative 4d. And I forgot to put equal b here. So to make sure each step you have an equation. Negative a divided by negative 1 is a positive a. And there's your answer. That is your b. Okay? Oops, I didn't mean to. So that's negative 4b here, negative 4d here. And there's your answer. All right, so that was number 9. Let's look at number 10. I want to do number 10. Okay, number 10, I have 5 times 2x plus 3y is equal to 2y plus 6. And you want to solve, let's say you want to solve for x. So notice that the variable x only shows up on the left-hand side. And when I look at where it shows up in this set of parentheses right here, and this set of parentheses is made up of 2 terms. So if you think about it, this term here that involves the variable I'm looking for is part of this expression right here. So what you may want to do is, at this point, go ahead and use a distributive property. So we're going to multiply both of those terms by 5. So I get 5 times 2x is 10x. 5 times 3y is 15y, equal 2y plus 6. All right? Now remember, solving for x, right? So you see, now it kind of looks easier to deal with. This is the term that involves the variable x. I'm adding that 10x to 15y, so I need to get rid of this 15y. I want to bring 15y to the other side. So I'm going to subtract 15y from both sides. But I'm going to go ahead and align my like terms, is that put the y's under each other. Combining like terms, 15y subtract 15y is 0. And so I get 10x plus 0 is 10x, equal 2y minus 15y is a negative 13y. So I get negative 13y plus 6. And then remember to solve for x, right? So to get x by itself, right now I'm multiplying x by 10. The opposite of multiplication is division. So I'm going to divide both sides by 10, just like this. The whole thing being divided by 10. And so simplifying, 10 divided by 10 is 1. 1 times x is x. So I get x equal negative 13y plus 6 divided by 10. And there's your answer. All right, so that's all you do. And then finally, let's make this the last one. So here's number 11. 6 divided by x minus 2y is equal to 8 minus 5y. And let's say you want to solve for x in this one. Okay, so I'm going to solve for x. So if you think about this, notice that, and this is going to be a little bit more difficult to deal with, but we can do this. Notice that this is the only term that involves the variable x. Every other term does not have the variable x. It's a little bit more complicated, though, because the variable I'm looking for is in the denominator. So some students have a little bit difficulty when dealing with the variables that are located in the denominator. But let's just go ahead and see what we can do. So here's the term that involves the variable I'm looking for. So I'm going to kind of hide it for a moment. So this term, though, I'm subtracting 2y. So at that point, let's go ahead and bring this 2y to the other side, meaning that the opposite of subtracting 2y is to add 2y to both sides. So I'm going to go ahead, Just like I did in this one, where I align my like terms, I'm going to do the same thing here. Combining like terms, a negative 2y and a positive 2y is 0. So I get 6 divided by x is equal to, and then 8. A negative 5y plus 2y is a negative 3y. So that's where I'm at. Okay? All right. Now, at that point, here's what I would do. The variable I'm looking for is in the denominator. So let's go ahead and clear those fractions. So to get rid of this x, this factor of x that's in the denominator, let's go ahead and multiply both sides by x. So let's go ahead and do that. Let's go ahead and multiply both sides by x. I get 6 divided by x equals 8 minus 3y. So I'm going to say times x. And then notice, though, every term here, so remember you multiply both sides by x. So this fraction divided by x and these two terms, so I'm going to put that in parentheses, those two terms have to also be multiplied by x. All right, now let's go ahead and reduce. The x divided by x is 1, so meaning that these x's divide out, so live with factors of 1. 1 times 6 is 6, equal x times 8 minus 3y. All right, now here's what I want you to notice. Don't distribute. Leave it as that, because if you distribute, you're going to notice you have to factor out the x anyway. So leave it as what you see, x times 8 minus 3y, because remember, you're solving for x, right? This is the x you're looking for. Right now, I'm taking this factor of x and I'm multiplying it by 8 minus 3y. The opposite of multiplication is division. So to get x by itself, I'll go ahead and just rewrite this over. To get x by itself, since I'm multiplying x by 8 minus 3y, the opposite of multiplication is division. So let's go ahead and divide by 8 minus 3y. And so notice these 8 minus 3y's divide out. You get x times 1 is x. You get x equal 6 divided by 8 minus 3y. And there's your answer. And so that's it. And so that should help you with understanding how to solve for a particular variable when given a literal equation. So we kind of did multiple types. We had, in some of them we used a distributive property, and some we multiplied both sides by the least common denominator. And then we had some where the variable was on both sides, and so on. So that should help you with some of the problems you'll see on your homework or on other assignments. All right, so that is it.